now. And welcome so much to Talking Data Equity for Friday, April 14th. My name is Heather Kraus, and Talking Data Equity is part of the We All Count community, and We All Count is a project for equity in all things data. And one of my very, very favorite parts of my week, and what we do in Talking Data Equity, is anybody who's interested in ways to think about or practical, concrete ways to embed equity in data can join us for an informal conversation Fridays at noon. And you can find the list of topics always on the Talking Data Equity website, the Talking Data Equity page on our website, if you're ever wondering what's happening in any given week. And sometimes we talk about very specific ideas or tools or theories, and sometimes we have a guest speaker. Today we have a guest speaker, and it's a much requested guest speaker. Today we have Jen Alford-Teaster. Is it Teaster or Tester? I've just realized I never asked.
It's Alford-Teaster, but you know, some folks, I've inadvertently gotten mail that says Mrs. Keister, so at least you didn't say that.
I asked a bunch of other questions, but I didn't ask that question. So thank you for sharing your last name. Jen is amazing. Jen is the director of the Data Analytics Core and a senior research scientist at the Dartmouth Institute for Health Policy. You may know that institute because they produce something that's super cool called the Dartmouth Atlas, and they're working hard on some equity work with that atlas. And Jen is a geographer and knows a lot about maps. So she is here today to talk to us about equity and maps. And like usual, you can feel free to use the chat function as much as you'd like. And you can use the chat function with the drop-down menu set to everyone, which means everybody will see what you have to say, or you can direct message me and I will amplify your question or your comment without attaching it to your name. And normally we ask you to stay muted during our guest speakers, but Jen is a seasoned teacher and she has said that she doesn't mind at all if you want to raise your hand on Zoom and ask a question in the moment. So totally up to you. You can put your ideas and have a conversation in the chat. And if you want to ask in real time a question, you can just raise your hand and go for it. So having said all of that, I'm going to turn the mic over to Jen and the screen. And I just really want to say thank you so much for coming. I know that A, you're very busy, and also B, I believe that it's very, very unseasonably warm where you are. And so thank you for being inside.
Yeah, thank you so much, Heather and the We All Count team for having me. I'm really, really excited to be here. And I do want to give a special shout out to my colleagues at the Dartmouth Institute who are here and team members from the Data Analytic Core who have been interested in hearing the talk as well. My name, as Heather said, is Jennifer Alford-Teaster. I'm a senior research scientist and the director of the Data Analytic Core. I am so thrilled to see all of you here on a Friday afternoon. And to reiterate what Heather said, I am a lecturer and I have taught courses. So I am entirely comfortable if you want to interrupt me for a point of clarification or have a thought, or you know, you want to turn your video on because you have a cool dog or a cat that you'd like me to see. I'm a big fan of those things too. But I am going to do a little bit of level setting today. I'm going to walk through a few slides on just basics around the discipline of geography and geographic information systems. Because there are so many people on this Zoom and I have no idea who and who's coming, what your field and background are, I think as I start talking about examples, I think it's important to ground you in some of those methodological approaches that could be helpful when you're thinking about the topics that I'm talking about. So let's see if I can do my screen. And I have turned off my chat box. So please do raise your hand because I can see folks in the visual panel. So from current slide. as you tell, I went through and practiced this today. Okay. So today we're going to be talking about mapping inequity. And, this topic is often referred to as critical geography. And critical geography is what you would think it sounds like. It's sort of thinking deeply and intentionally about the tools that you use in your mapping and geographic analysis. A lot of the stuff that Heather has talked to our team about in the We All Count process really resonates with me as a geographer, asking about intentionality, asking about the data sources, the limitations, and really couching, outcomes and, in those limitations. So that when you're making decisions on your data, that those decisions are really based off of that full scope of understanding. And so for me, when when Heather asked me about giving a talk today, I thought it was really important to walk through the sort of the basics of geography and geographic information systems, and then discuss those limits of the methodological approaches. So these are really just like a little nail scrape of the top of this field of geography. So if you have questions that are sort of outside the scope of this foundational talk, please do either ask me now or follow up. I'll have my email at the end, and I'd be really interested to hear from you. So geography as a discipline is to understand the spatial effects of human activity on Earth. And we tend to look at these effects through the physical as well as the cultural distribution. It's more than just capitals. I know often when people ask me about my role and my job and my training, I'm often asked if I know all the capitals of the United States and major countries, and I do not. But specialization in this field can include population demographics, land use, and municipal planning, as you see here listed on the slide. But the particular focus that I'm thinking about today is on this subdiscipline of critical geography, which seeks to examine that influence that we have on our environment, and understanding that the bias that we have as lived individuals and in the methods really affect that examination. So geography in its discipline, one of the main tools that we use in our discipline are maps. And we have used these historically to understand the effect of human activity across the globe, because they are visually compelling. And they are easily translated in, for individuals, I think of maps as the equivalent of a statistician's chart or graph. The difference, and this is often what I talk to students about, is that because maps are visual in nature, and we as human beings have a tendency to sort of imagine and see things in a spatial temporal fashion, that we tend to sort of assume that what we're looking at on a map is, can be taken at face value, and that may or may not be true. So one of the most popular uses or case examples of mapping in public health is the cholera epidemic of 1854, because it was theorized that the cholera epidemic was coming from an environmental risk factor. And it was only until it was put on the map that we were able to see the magnitude of cases surrounding Pump at Broad Street. So geographic information systems is one of the mechanisms that geographers use in order to analyze geographic data. So this can be spatial, and there's sorry, those are my dogs, a link between spatial and tabular information, which enables us as analysts to look at patterns, relationships, and trends. And we tend to, in geography and GIS, note that there are 5 components to an effective GIS. So that would be your software, of course, which most people tend to think of the geographic information systems as. But it also includes the type of data that you use, vector, which is points, lines, and polygons, raster, which are images that are tied to geographic locations in the world, image data, and attribute data that's associated with those data points. The hardware that you use can affect it, the people that you use, their training, the methods, guidelines, specifications associated with those specific applications of GIS all have an impact on how we utilize and interpret geographic data. So this is a visual from Environmental Systems Research Institute on how it works. So essentially a geographic information system layers data on top of one another. So in that layering, we also experience, in the choices that we use in the layering of that data, we may inadvertently, unintentionally be, suggesting something within the map. And in GIS, we have essentially two domains of analysis. We have thematic analysis, which, patterns and features, quantity, density, proximity, and change. And towards the end of this presentation, I will give you a couple of examples of these things. And then we also have statistical data analysis. So geographic measurement, looking at phenomenon over space. The example I use here is how many cases exist within a radon hotspot, and quantitative analysis that can, work to interpolate missing data points. We could look at the presence of certain geographic features that affect other features. So if you live in a warm area, are you more likely to have, increased outbreak of infectious diseases, things of that nature. And earlier, I had mentioned that there is a broad use of GIS in geography, in the discipline of geography, but applications of GIS in health and medicine are also broad as well. We've got vital events, birth, death, immunizations, tracking where people are living, infrastructure. This is, municipal planning. It can be also hospitals. I used to work at a fire department. I used to use geographic information systems to plan for where we were going to put new fire stations. Its use is in program data, facilities, and services at different scales as well. An increasingly popular use of GIS in facilities is the micro scale, administrative boundaries, and environmental. And you can see the many examples I have listed here. So one key piece of the geography and the GIS and the tools used in mapping that I really like to reinforce with people is this element of cartography, because cartography, as noted here, the definition is the art and science of maps. And that alone in that definition should tell you it's, the decisions you're using in the use of mapping do have an impact on the interpretation of that, depending on the audience that you are working with. A perfect example of this is I was working on a map, some graphs earlier today, and one of my co-authors reminded me that I was using red, green, blue in one of my charts. And she said, well, we need to be mindful of individuals living with color blindness. And I was like, gosh, yeah, of course, like that makes complete sense, because the interpretation, the visual representation can mean things to different people. So when I'm talking to folks about maps and these cartographic principles, one of the things I think is, like, if you remember only one slide from this presentation, when you were looking at maps, you could ask yourself these questions to help you gain a better understanding of what the limitations of that map may be. Ask yourself, what is the purpose of this map? Is the purpose of this map to communicate location? Is the purpose of this map to communicate an idea? Is the purpose of this map to center a certain population or geographic location? Is the purpose of this map to make a case? Who is the audience? Usually in mapping, so a map that you might make for public discourse may be different than maps that you are sharing with students, or maybe different than maps that you may be sharing with colleagues. The individuals coming, the audience might be financial people, it might be people in municipal planning, and then also asking yourself the underlying characteristics and the availability of the data. Sometimes, especially in geography, there are a lot of limitations in the data sets that are given and used in geographic analysis. And I'll talk about that a little bit in the geographic access examples that I use, because I do a lot of work at a national level, and we are often utilizing street centerline data that is, of course, reflective of the underlying transportation network, but has limitations in and of itself, much so that maybe we don't account for people who travel, people in like Washington State who might take a ferry from one of the islands off the coast, or, the travel time may not be updated regularly. I know when I worked at the city of Greensboro in the fire department, I was updating the street center line data monthly because of streets that would go offline for, work through the Department of Transportation or otherwise. And that can have real world implications into the summary statistics that are generated based off of what we consider travel time. The medium for the data, this is one I love. Sometimes people think of maps and they think of those dusty old things that we find in the library, but now we see maps everywhere. We see them on the internet. We see them on cell phones. We see them on our iPad. And so those different mediums can have different impacts on how people ingest information and the story and the messaging that they get from those mediums. And then as the map maker, you would then think about how much detail should be included, because that amount of detail can tell you lots of things about who the map maker was it funded by somebody who has an invested interest in delivering a specific kind of message to you, and things of that nature. So I'm going to pause just for a moment and ask Heather if there have been any questions raised.
Nope, we're good to go.
Okay, great. So I'm going to move into just like this, like a small little overview of, just at baseline, the methodological limitations of a map and map projections in and of themselves. So a map projection is what you would think. It's, the process of converting a three-dimensional surface to a two-dimensional plane. Latitude and longitude. The latitude is the east-west around the Earth's surface. Longitude is north-south. I promise I'm not going to go into great technical detail because Heather asked me not to. But I do think it's really important to just see visually how maps are sort of transformed from the real world into a model. The purpose of that is to underscore the many ways for which we can obscure the underlying geometry of the data. Something else I really like to underscore with students and those who are interested in mapping is in that distortion, in that transformation, you can only maintain two properties at one time: area, shape, direction, and distance. So we can't maintain all four of these different map properties, which is really important. So for example, one of the most common maps that are used is the Mercator, and the Mercator projection, which if folks are familiar with projections, that's the one they're usually most familiar with. And that one, manages direction because it was often used in seafaring exploits. So, keep in mind, only two properties at a time. And I love to show this example to folks because people tend to think of, maps as sort of, once it's up there, people believe it to be the truth, but it is a version of the truth. So for example, look at the difference between Greenland and Mercator, and the Mercator projection versus the equal area projection versus the Robinson projection. These look like three different continents, right? Like three different countries. So, but they're not, they're like very, they're just stretched. The other thing that's important to notice about these maps, which I wish that there was noted in the graphic itself, is notice that the which country is placed at the center, which region of the world is centered in the map. That's something that, in the United States, we have in the global north predisposition to put, white countries at the center of maps and map making when we work with them. And so seeing a map from a different perspective can be a little bit jarring because we've established that as normative.
Jen, can I interrupt with two really, really good questions on this topic? Because this, I think, is sparking a ton of interest. The first question is I'm just going to read it. So to make sure that I understand the three maps we're looking at here, the Mercator, the Robinson, and the equal area projection, they are each maintaining accuracy for a different set of two properties?
Correct.
And is there any way we can tell when we look at a map which two properties they're maintaining?
So it depends, right? So if you're working in a
Mhm.
GIS system, you can look up the details of the map itself.
Okay, so that's in the metadata of
That's
a
in the
GIS
metadata
map?
of some maps, not
Okay.
always.
Okay.
Some of it is as you begin to work with maps and you start to notice these things and you develop, you begin to develop a sense of which map, like I can always tell if there's a Mercator projection, especially if we're looking at the United States. So if you look at the border of the United States, it's flat. And if you look at the equal area projection, which, preserves shape and
Got it.
area, it is, rounded at the top. So, part of it is experience and working with maps and gaining familiarity, depending on the,
Okay.
medium that you're accessing. You may be able to look at the metadata. It should be able to tell you. If not, it's just a matter of getting familiar with the various projections that you work with in your data. And so for those folks who are working in the ESRI data and environment and shapefiles and, there should be, that should be in your metadata. And for those
Okay.
who are already in GIS, there are like hundreds of differences of, projections. So, you might have, be working in a local area and use Universal Transverse Mercator, which is a much smaller version specific to, an area in order to reduce distortion in that area. But it does not matter which projection you're using, you're going to have some form of distortion. And that's the key message that I want to drive home from looking at these maps.
I think we've got it. I don't think I'll elevate any more questions, but just to say there's a lot of conversation in the chat about how many of the projections we're used to seeing make the continent of Africa look an area very small compared to Europe.
Yes.
Just
So that's where this is. Yes. So this is one of the things I drive home with students that I'm working with is that, pay attention to what that is normalizing, which populations we're normalizing, stereotypes maybe perpetuating and unknowingly participating in. So this is, harkens back to the sort of examining your audience, examining the data that's used and the projections. So, many people who are not in geography consume maps or even have opportunities now to create maps with freeware or, get in and because you can push some buttons, generate a map, and then don't really understand the limitations of what they've generated. I've, experienced that, with individuals who getting map making and have access to the free software and then generate something and then, not understanding its limitations, perpetuate the results of that map as truth. It's one version of the truth. And that version of the truth comes with caveats. And so, we don't do this in statistics, right? If you generate a chart, people tend to be much more careful or understand that statistics themselves can be used to influence people's understanding, but people don't necessarily attribute that same sort of cautiousness with maps and map making.
Excellent. Thank you.
Mm-hmm. So again, 2 of the 4 at a time, no more than that. The other thing I just sort of wanted to briefly walk through is, your eyes tend to, when you're looking at maps in the Western world, go from the top left to the bottom right. So interplanar organization has an influence of orientation for you and spatial recognition. So, tend to also the colors we choose to elevate or retreat in the maps. So this is considered a balanced map. So we're looking here at Mexico. That's really fast. The other piece that is super interesting, like I mentioned earlier, are these, the color theory. In cartography, we consider, the art and science. Well, the art is this, and how our eyes perceive and interpret colors, hues, value, chroma. These connotations evoke different reactions from different people. People who have color blindness or living with color blindness may see the results of your map in a wildly different way than you intended. They might not be able to distinguish between hues and chrome and value in a map if you're not cautious. So it's, commonly understood in cartography that the average eye can distinguish between 8 different colors on a scale. I myself try not to put that many colors on a map or different hues or differences on a map because it can still be difficult for folks at 8 different categories. So I'm just going to show you a few examples of types of maps in healthcare. So a chloropleth map is one that people are most familiar with. So it uses shading and geographic boundaries to indicate distance or proximity, or magnitude and values. So here we're looking at a map I created, I don't know, maybe 10 years ago, looking at the distance to mammography in the United States. This is for ultrasound and MRIs. Here we have an example of suicide death rates in New Hampshire. This is, where this is in a raster, this is an image, you're able to see more gradation. Here is by political boundary in New Hampshire County. We also have heat maps, density, and I'll show you how these are created in just a minute so you have an understanding of what the limitations are of these types of maps, but these tend to be cluster maps demonstrating the intensity of some phenomenon across a geographic space. So I'm going to show you 2 examples. The first I'm going to show you is on a hospital catchment reach. So I am a geographer. One of my main specialty and interest in my work is examining geographic access to healthcare services with a particular focus on rural cancer care. Geographic access is one component of access to healthcare services. So I do want to acknowledge that there are 5 different components of healthcare access, which include accessibility, affordability, and let's see, I forgot the other few. Affordability, accessibility, financial, and I can't remember the other. I have it listed in the slides in my notes, but I'm going to focus here on this specific aspect of accessibility. So we tend to think of geographic access as the absence of barriers to accessing care when you need it, physical access, whether or not you have adequate transportation or a physical challenge to receiving that care. I, in my work, tend to focus on the methodological challenges in accessing and in examining geographic access. So for geographic access to healthcare facilities, we model it, as I noted, on transportation network infrastructure, which inherently has limitations depending on the scale at which you're looking at. We look at both the distribution and the supply, supply of hospital or care facility, and then patients or potential patients or populations that could be served. So, as this geographic access field has evolved, historically folks used a Euclidean distance or straight line distance, which is, not necessarily reflective of how people reach healthcare access. But as noted here, refinements in models and advances in modeling software have led to increased accuracy, although I would caution that it still contains limitations in the analysis. So, one of those advancements has been the use of tools to generate service areas or examining closest facility, routing in the most efficient way, location allocation, then origin destination matrices, which are a special case of closest facility. So essentially modeling along the transportation network specifically, and usually and typically it's on a street network, although recognizing that there are waterways that people may use, biking, walking, and other modes of transportation. So I wanted to show this example of a paper that I worked on in 2014, which was published in 2017. And where we were looking at, for the National Cancer Institute, there are primary catchment areas for each of the designation of the National Cancer Institutes. And we thought, gosh, many of these have expanded to include satellite facilities, and they're advertising these as meeting the needs of rural communities. So we wondered what additional reach those satellites are actually providing for these geographies. And when we went through this project, we realized that actually it's not so much that they're providing, substantial additional geographic reach into rural communities. It's just the additional facility helped reduce the load on the parent facility. So you can see here, we've got our parent locations and our satellite locations, and then generated travel times based off of the underlying transportation network to see if it greatly expanded into other geographies. So as you can see here are some IQRs, interquartile ranges associated with some of the travel time savings. And you see in some of the isolated and small rural, there appears to be savings. But also this is one, when you're looking at the travel time, this is one way indication. So it may be greater. Oh, I'm kind of flying through these things because I want to give folks time for questions. Oh, great. And so the other example I was going to use, so before I proceed, one of the things that I think is really important to understand when you're looking at maps like this, I often would say and put in my limitations for the papers, and you would see it in this paper as well, is that, in this map, what we're looking at are travel times based off of road networks, and we are making assumptions that individuals have access to a vehicle in this analysis. We also do not account for people who walk or who take their bikes or take public transportation. So often when you're looking at these geographic access studies, usually what they're telling you is about the population that has access to a vehicle and can travel along a major road infrastructure. So that is an important takeaway that I'd like you to keep in mind when you're looking at geographic access maps.
Can I elevate a couple questions that we have,
Sure.
Jen?
Yeah,
Because this is a really, really great example, and especially about what you just shared about the fact that remember that the times that we're showing here are in privately owned cars. So a couple of questions. I'm going to ask two questions at once because I think probably they go together. One is like, who is in this? Like if we're talking about a health center in Indiana, how do you know like who to include in the travel time? Nobody that lives in California is included in that. How do you know? And second thing, has anybody looked at what the differences are? Like, do you know of any examples of this where there might be three charts, one chart that shows private car, one chart that shows public transportation, one chart that shows like biking and walking? Do they exist? Not for this study, but like at all.
Yeah. So these are great questions. And so this is one to the second question. I don't know of any, but they do. I don't know of any, but it's something I've wanted to do at a national level to look at the differences. If we had a multimodal transportation network, what would it look like in terms of access? More so at the scale that we're looking at this small scale map. And so small scale is where you're looking at a larger geographic area, and a large scale map is when you're zoomed in and looking at the features in a much larger way. So when you're looking at a map like this, and this is a national level, there are computational challenges to having multimodal transportation networks. So as you can see from this map, we had taken an origin destination matrix. So for every origin, so we took we did a travel time analysis based off of the underlying infrastructure for the entire United States, cut it off at the 3-hour mark because we sort of assumed that, and that's the key word, assumed that people would be willing to drive up to 3 hours to receive cancer care. This may or may not be true, but we figured 3 hours in a day. So if you're traveling for, an appointment, you are willing to go 3 hours, have the appointment, turn around and come back home. So we cut it off at 3 hours for that reason. And then what we did is a spatial overlay of the boundary of the full extent of that travel time and captured the underlying geography. And that's what you're seeing here in this IQR. So it all individuals and the population side are captured. And this doesn't include actual patient data. There are studies that do that. There are studies that examine actual patient level data. So in 2015, I wrote a paper on the closest versus actual, because often in geographic studies, people assume that the closest facility is the one that people use. And I've had lots of conversations with colleagues about how that's probably not true. I mean, even thinking about our own anecdotal personal experiences, I work at a hospital, and even, I would be more likely to do an appointment while I'm at work during the workday at the hospital, even though it's 45 minutes away, than go to the closest facility, which is actually 30 minutes from here. So in 2015, I wrote a paper on looking exactly at this, at breast cancer registry data across 5 registries in the United States. Again, with some scale-based dependencies, we couldn't, we had to accumulate, because of the limitations in the institutional review board, we had to limit the location. So we couldn't report on individual level metrics. We'd had to accumulate up at a higher geography to mask the underlying data. So there's a phenomenon called the modifiable aerial unit problem. Remember it, MOP? And the modifiable aerial unit problem, at the resolution that you capture the data, you lose some specificity in that data. So we accumulated it up at, I think it was zip code level. So we could mask the underlying data because we were working specifically with patient data, and then reported out on whether or not people were using their closest versus actual. And more oftentimes than not, if you were in an urban community or a highly dense community, you were more likely to not choose the one closest to you. But if you were living in a rural or isolated community, you were more likely to use the closest facility. So, did you have a follow-up question for that? Okay, I see you smiling.
I have many. We're going to need you to come back for sure, because but there is someone that wants to know why Hawaii and not Alaska is on this map, because they live in Alaska. And
thank you so much. Okay. So
and they're like, this is a huge problem in Alaska.
Yes. So the infrastructure so one of the methodological challenges for using, one, there's not a National Cancer Institute in Alaska. 2, access for Alaska would incorporate, potentially flight or ferry. And the data set that we have couldn't accommodate that. So thank you for drawing attention to that. And so sometimes when we're talking about map inequity, some of the limitations have to do with the actual, analysis plan itself, and what's available in the data and what's available in the analysis tools.
Right. And it's so often a doubling down. Like, as soon as you said, well, there's no cancer, no cancer organization or something in Alaska.
National Cancer Institute.
So that's, doubling down on it. And so the follow-up question is, could there be a best practice that it's like acknowledge that it's not there?
Yes. So yes. So when we're working, so one of the ways in which we attempt to, in our limitation sections of our manuscripts, is to describe why certain populations are not represented. So one of the things that happens quite frequently and frustratingly, I'll say, in health health services research are the issues of small numbers. So we talk about this quite a bit. And then once you start adding small numbers to maps, the Institutional Review Board would not allow publication of data that would reveal someone's specific geographic location or the ability to reverse geocode where they live. So there are mechanisms and tools that you can use to mask, so if you've got a geography where you have like three patients who have a rare cancer and they are of a specific, population that is considered vulnerable, the Institutional Review Board would not allow us to report out on those values in a map or any way that could potentially be used to find the physical location of that individual. And that's something we want, right? Because we don't want to be, sort of unfairly approached by those not involved in the study about, our particular identities. It also has impact on how we represent geographic data and how we talk about it. But yes, one of the things we try to capture in the limitations, in the manuscripts is who's not represented here and why.
Great. Thank you.
Mm-hmm.
Look fabulous.
Okay, so it's 12:45. So like I have this other example, which I could like bling through and just to show another way in which
go for it.
We can look at how we can look at and use geographic information sciences to explore issues of health and healthcare. So this was a study I had worked on, oh gosh, I think 2007 or 2008. The reason why I'm using this, even though it's past the 5-year standard for when you put something in a literature review, is because of the method. So we were looking at a longitudinal prospective cohort study, which is a population study to identify risk exposures for children that are related to violence. And one of those risk factors is associated with alcohol. And the investigators that I was working with, one was a clinician, was sort of theorizing that, if you have if alcohol is readily available to you or present in the community, you are more likely to have, maybe violent outcomes. So one of the tools that we use to estimate this is something called kernel density estimation, KDE. It's an interpolation metric. So what you're looking at here is points. And so let's just say for the purposes of this example that these are alcohol outlets. And so each individual point is an alcohol outlet, but what we'd like to know is over space, do we have a cluster or concentration of these alcohol outlets for a particular geography? So how we calculate this is we determine a bandwidth, that circle that zooms out and it captures all of the points that fall within that circle. And you go through the entire grid set. And then what it does is that concentration is then attributed to that underlying grid. And so we had developed this for the entire United States. I was tempted to ask folks if you knew which projection this is, but I don't want to quiz anybody. Albers equal area. You can tell by the swooping top part of the United States. So because I wanted to preserve area, because I'm calculating the number of points within a geographic area. So you can see this sort of case density of alcohol outlets distributed across the United States. We looked at the population per square mile. And as I'd mentioned earlier, because of we were looking at patients who are exposed, or populations that are exposed to this, we were asked by the Institutional Review Board to apply something called a dither, which randomly offsets that point location within a spatial distance. So you don't really know the true location of an individual. And so from the results of this, we had, higher proportions of Black race and Latino ethnicity, higher poverty, lower education, higher crowding, all predict a higher retail density per 1,000. It just sort of suggests that the increased risk for alcohol-related morbidity and mortality. And we were suggesting that, if these results could be used in a state-by-state analysis, because you'd be able to get at a smaller, a more precise geographic location, which is influenced by other things outside of just the presence of these alcohol outlets, such as, local policies around consumption and availability and things of that nature. So this is a lot, I know.
Yeah, it's great.
So I'm going to stop the sharing, and I welcome all questions, inquiries, follow up. If you get to be thinking about it later and you want to like email me or have a call, I'm more than happy to jump on with you. This is one of my favorite topics. Do we have questions in the chat?
Yes, there's tons of questions in the chat. Thank you so much, Jen. That was
my
very,
pleasure.
very insightful. We haven't had anything like this. Before we get to the chat, does anybody in the room want to raise their hand and unmute?
Yeah, let me
There's
see your faces, people.
Bunch of Jen also wants you to come off video.
Yeah.
All right, go ahead, Lindsay.
Hi.
Hi.
Thanks for taking my question. So I recently went to a city webinar and they were talking about some data sources that are available for people in the city to use when trying to understand transportation. And they recently switched to like this data mining platform that's mining the data from car computer systems themselves. So it's inherently not including cars that are older, which would be owned by poorer people, and also really having challenges with including people on bikes and on foot. And then public transportation data is a whole other data set. But so we as a city are like encouraged to use this data to inform decision making. They literally plan how to build transit routes around this data. And I'm just wondering if, in your work, you've encountered situations where it feels like we're using the data about how things currently are to design what we're going to have in the future, rather than being like, what would a transportation system that actually works for people look like? And so if you worry about that, if you've seen worrying examples of that, or if you have any ways that, you and your work mitigate that, that's my question. Thank you for coming and giving us your time and expertise.
Yeah, thank you, Lindsay, for coming off of your mute and showing me your face and giving me your enthusiastic energy. I used to work at a fire department in the city of Greensboro, North Carolina, and I often would take my maps to the city council to talk about the limitations of infrastructure issues within the city, specific to things like cul-de-sacs, because they sound great in nature, but when you start putting down a cul-de-sac, you actually create a lot of inaccessibility in cities. So yes, I have seen that. I have run into that. I have worked to address ways in which we can model for better and more accessible cities of nature. My husband, Jason, used to work in the Department of Transportation at the city of Greensboro, and they, would map out, and he's a geographer as well. So I guess my take home is hire geographers, because they'll help point out all the infrastructure issues and accessibility in a city. But yes, so I have seen that, and that is true. And I would suggest that part of what is really important is you have an understanding of these limitations and vocalizing that where you feel comfortable doing so. And, talking to colleagues and going to, places where people are making decisions, city council, local, state, federal, and advocating for data sets that are more comprehensive, speaking to the limitations of the data. People often don't understand the way that the information that is presented to them is inherent with limitations. And so some of it is just being vocal about it with your colleagues and your peers and those in the decision-making places when you feel comfortable. But that's a great question.
It is a great question, getting a lot of amplification in the chat. And I think part of the question, if I understand it correctly, goes back to the way that they're getting their data to make those maps, which is,
Yes.
from new cars that have this stuff. And that must be a problem everywhere. Are you aware if anything exists that gives, there's there must be something that exists that you can put on a bike or put on a car that doesn't have a fancy GPS system if the person wants it, so that they can also be contributing like their movements to a city planner's understanding of what's going on. Does anything like that exist?
Well, so I would say it depends. And I think it depends on sort of the priorities and focus of individual municipal organizations. So I know, in North Carolina, there was a City of Greensboro Geographic Information Systems Division. We in New Hampshire don't necessarily have individual representation of people who have this level of, expertise with data at individual city level or even town level. Sensor data and this could be a whole other topic about the limitations in the capture of sensor data that is near constant. And most municipal organizations that I know, or even, planners, do not have the infrastructure to capture the volume of data that can be retrieved in sensor recording. There's a whole other topic around privacy of that level of data as well. And, when you're capturing that data, who it goes to, who has access to that, how, companies and organizations are tracking. I know in 2015 or 2016 had done a project on sort of web scraping or web mining the self-report of individuals on Twitter and the Twitter fire hose data of people talking about digital breast tomosynthesis. This is just my little plug for privacy, but be careful what you put online because that data can be made publicly available without your permission. And so, people would report all kinds of things related to our healthcare and healthcare behavior online. And so there's publicly available data, there's volunteered geographic information. There are now ways in which, images can be deconstructed to determine where your geographic location is just by the metadata associated with the imaging. So there is an overwhelming amount of geographic data available. And so some of the limitations for planning departments have to do with the architectural infrastructure of the database, and then the people being able to apply methods in an appropriate manner.
That's a really, really good point. There's a lot of response to that in the chat too, of course, in the United States around reproductive rights and all of that. So, yep, for sure. I also, here in Toronto, we were one of the cities that Google tried to purchase. And so we had to fight back hard and we won. They wanted to install, all their capture data. Okay, so we have about 2 or 3 minutes left before we are, I know, going to have to again think that this was an amazingly short, fast hour. I want to quickly remind you that we're next Friday, we are on with James Lee, who is the founder of Call Me Litin. And we're going to talk a lot about other names to use when collecting data about communities that are sometimes referred to as Hispanic, Latinx, Latina, Latino. We talked a lot about that in some other Talking Data Equities, and you folks really wanted to hear from James. So we have James next Friday. And I think just to give everyone the kindness of having a 3-minute break in their back-to-back world, we will wrap it up. And Jen, I hope you can see the chat because there's a huge round of applause and thank you. And we will, as you say, we just barely touched the surface of how important maps are. We all carry around probably way more maps than we could ever have imagined. And so, yeah, we'll definitely look forward to getting you back. We'll follow up with questions. We will put the link to this recording and all the resources Jen shared and that you folks shared in the chat so everybody has access to them. All right. So we'll leave it here. Thanks for coming, Jen. Have a great rest of your day.
Thank you all so much. It's just been such a pleasure, and hope to see you again. And otherwise, reach out to me at any time. I love to talk mapping and geography.
Excellent. Well, people will. And to everyone else, it really means the world to us that you want to keep coming back every Friday. Don't forget to let us know who else you want to hear from, what other topics you want to talk about, because we do this for you. So take good care of yourselves, take good care of each other, and have a great rest of your day. Bye, everybody.